All right, you guys, this is Chapter 10, Lecture 5. Chapter 10 is titled Calculation of Medication for Special Populations Based on Body Weight and Patient Age. And again, you should have already read the chapter, reviewed the PowerPoint provided to you within Blackboard, and also read the lecture notes provided to you within Blackboard before reviewing these lecture videos and starting on your some of the practice problems. I know some of you may get lost within the translation of those practice problems, but at least if you started, you kind of have an idea of how you're supposed to solve each of these questions. Now, so far, what you guys have learned in the first 4 lectures is that you have learned how to calculate the dose ordered using a few methods, all right, for special populations. Those methods are, one method is you use the body weight method, where you just basically, you take the patient's weight, and you multiply it by the weight of medication per units of weight. So that means that what I'm basically saying is that based off of the patient's weight, the patient weight could be in pounds, and you're going to multiply that by the dose regimen, where the weight of medication could be in milligram per kilogram. But you have to make sure that the pounds matches the regimen of the weight, which is kilograms. So you would have to change those pounds to kilograms in order to multiply that out, because the goal is you want your like units to cross out. So you want the units of the weight to cross out. The second method you guys have been using is the pediatric formulas, right? Those pediatric formulas, there's 3 of them that you've learned thus far. And those 3 formulas are, you have the Young's rule, where you take the patient's age in years over that patient's age in years plus 12 and multiply it by the adult dose. You're only going to use this formula if the patient is what? 12 months and older. Another formula that you guys have learned for your pediatric formula is your what? Your Clark's rule, where you take the patient's weight in pounds over 150 and multiply it by the what? The adult dose. In order to use this formula, the patient's weight has got to be in what? Pounds. All right. I'm going to use a new document here to keep going. The third pediatric formula that you guys learn to use is the what? The Fry's rule, where you take the patient's age in months over 150 and multiply it by the adult dose. You only use this formula if the patient is 11 months or younger. All right. So far, you have learned two major methods. You've learned your body weight method and your pediatric formula method, but within your pediatric formula method, you've learned 3 sub methods that you can use. But each of those formulas or each of those rules have special considerations that you have to take into consideration. Well, the next method that we're going to talk about, this I think can be the most difficult method, but I'm going to walk you guys through it. So the method number 3 that we are going to talk about, method number 3 is the body surface method. Out of all 3 methods, the body weight method, the pediatric formula method, and the body surface, or let me say body surface area method, let me specify, and we call this BSA. This method, the body surface area method, is the most accurate method. The reason why it's the most accurate method is because it deals with the patient's weight and their height. All right. So it has 2 components that it takes into consideration. It takes into consideration the body weight of the patient and the height of the patient. So this method, the body surface area method, is the most accurate method out of all 3 methods. It's the most accurate method out of the body weight method. It's the most accurate method out of the pediatric formula method. But you can't use the body surface area method unless it's based off of the information that's given. All right. So there are 2 formulas that I want you guys to keep in mind. If you read the book, your book speaks on what they call a nomogram. And if you turn to page 360 and 361, those are examples of a nomogram. And basically, with a nomogram, what you're doing is that you are taking the height of the patient, the weight of the patient, and you're using a ruler and you're drawing a straight line in between each of those indications, the height and the weight, and you're determining where does that line cross on the quote-unquote normal height or weight for a patient on a nomogram. Well, one of the things I'm going to tell you is that a nomogram, all right, provides an approximate body surface area calculation. All right. And that body surface area calculation has the units of meter squared. All right. So I'm not going to teach you how to use the nomogram because we don't use that in the pharmacy department. All right. We're not going to use the nomogram. What you guys are going to do, if you guys know me so well, by now you should, is that we're going to use a formula, 2 different formulas to determine the body surface area for a patient. All right. So I'm going to use a new. So what we are going to do is, in order for us to determine the accurate body surface area, and I'm put meters squared because that's the units. In order to determine the accurate body surface area of a patient, we must use one of the two formulas. All right. So formula number one. All right. Formula number one. You guys need to make sure you have this written down. It is within your equivalence sheet that I've provided you. But formula number one is that meters squared equals the square root of the patient's height, if in centimeters, times kilograms over 3,600. All right. Formula number two, same thing, meters squared, which is body surface area, is the patient's height in inches times what? Pounds over the 3131. So instead of us using a nomogram, and getting an approximate body surface area, we're going to use these two formulas, which is going to provide us the accurate body surface area. All right. So when you guys are determining, or when you're using this calculation, remember your body surface area is always rounded to the 100th place. So your final answer, when you plug everything within your calculator and get the square root, your final answer should be to the what? To the 100th place, which is 2 digits behind the decimal. This is very important because this will change your answer when you're determining the dose order. Now, when calculating the body surface area, you're just taking one step towards determining what the dose is. All right? So, in the next lecture, we're going to pick this right back up, and I'm going to start doing some practice problems based off of the body surface area formula. Again, if you have any questions, feel free to send me an email.